Hey everyone, welcome back. So in the last video we started problems based on arrays. So today we are going to solve another problem, merge sorted arrays, which is also easy questions from the Leetcode. But this question you can say is a part of one of the bigger problems which you are going to learn after learning a recursion, which is merge sort algorithm. There is an algorithm which is merge sort. So you can say this concept will be used in that algorithm. So let's see what is the problem. You have given two arrays, nums1 and nums2. Both of them are of different size. Means this one we can take size of m and this one we can take a size of n. So the number of elements will be different in both of the arrays, but both of them are sorted in the ascending order. So you have something like this, and here you can take 5 and 6. So your both arrays are sorted and the size of them are m and n. Now the question is asking to merge both of the arrays into the single array, but this should be in sorted order. So it will become like this. Okay, let's take another example. Let's say we have nums1 and nums2 like this. Now our output array will be 0 1 1 2 2 3 4, right? It should be sorted and merged. The first solution you will be getting is that we can create an array, and in that array we can insert all the values. Let's say I created a answer array. So first I will pick values from my first array, so I will insert into my answer array. Then I will pick values from the second array and then insert into the array. Then after doing it, I can sort the array. After sorting it, it will become our merge sorted array. So first I will declare new array, insert values from both arrays, and third is sort. So in that way we will be able to get our answer, right? Let's write a code here. We already given nums1, nums2, size m and size n. Now we just have to declare a vector of answer and we will run our loop. Let's first run a loop for a nums1 and we can push back our values. Similarly, we can write our loop for the second array and insert our values into the answer array or vector. So in this way we will be able to add all the values into the answer array. After that we just have to sort the array and we can here return our answer. So we can do it like this. But now what is the time and space complexity of this code? So here we are running our loop for m times. Here we are running our loop for n times. Here we are sorting, we are applying on the answer. Now answer vector contains values from the nums1 and the values from the num2s. So we can say our array size will become m plus n, right? Because it contains values from both the arrays. So size will become m plus n. When we use sort function, it takes time complexity into n log n. So in this case it will take m plus n log m plus n. So this will be our time complexity of the sort function. If we write total time complexity, it will become n plus m plus n log m plus n, and space complexity will be big of m plus n. Okay, this space complexity is for answer. Okay, this is not a extra space, but it is for a answer. So we can say space complexity is without any extra, it is 1, but with the answer vector we can say m plus n. Now let's focus on the time complexity. We have time complexity n plus m plus n log m plus n. Okay, but the question have asked us to solve this problem in the time complexity of m plus n. So that means we cannot use our sort function because sort function is taking extra time complexity. Okay, so let's take our array 1 here, 1 1 2 4 and 0 2 3. So we have these two arrays and they are already in sorted order. So can we somehow merge both the arrays so we don't have to sort them? So for that there is a technique which is called two pointer. In this technique we just use two indexes simultaneously. Means if I am using one index here I, then I will be using another indexes in this array. Even if we are using another indexes here instead of here in a single array simultaneously, we can say it is a two pointer algorithm. Okay, most of the time we run a loop and only one index means only I is iterating over the array, but in this case I and j, two pointers, are iterating over the array. That's why it is called two pointer. In the future we are going to solve problems on two pointer also, but two pointer is just a technique in which we are iterating over the elements simultaneously using two iterators I and j. If we are using another key, then we can say it is a three pointer, right? So let's focus on two pointer. So if you look at it, we have I here, and j here, both are at the first position. Now if you compare both the values, which one is smaller? It is a 0, so we will take our value 0 and move our j to the next value, because we have taken a 0. Now we don't have to compare with any other value, so we took a 0 and moved to the next index, but I is still at the 0th index because we haven't took our value 1. So I will remain at the same position and j will move to the next position. Now let's compare this 1 and this 2. Which one is smaller? Our 1 value is smaller, so we will insert 1 and move to the next value. Now again we will compare which one is smaller between 1 and 2. 1 is smaller, then we will insert 1 again, then we will move I to the next value. Now we will compare again which one is smaller. Both of them are equal, so we can take 2 from any of the array and move the indexes. So we will take a 2 and this time we are going to move our I and j simultaneously, right? Because both the values are same, but we have to pick only one value. Now again we will convert 4 and 3. So 3 is smaller, we will pick 3 and our j will reach at the end. As our j reached at the end, we cannot compare for this out of the index value, because as the j will be out the boundary, it will throw an error. So what we have to do, when j reached here, we have to stop our loop completely. So if we stop our loop here, but there is one value still available which we haven't picked, right? But if you see that from 1 to 2 in this range and in this range, we have already picked the values which are sorted, and the remaining values will be always sorted and will be greater than these values. So the remaining values we can directly insert into the answer array. Okay, so what we are doing, we are having one pointer at the nums1 and another pointers at the num2 and comparing values between them. Which one is smaller, we will pick that value and move to the next value. So how we are going to write a code for this? So nums1, nums2 given, m and n also given. Now we have to run our loops and also use I and j simultaneously. So in that case we cannot take a for loop. If we take a for loop, you have to handle both the I and j in single for loop and it will become complicated. So for that we will be using while loop. Okay, first we will declare our I0 and j0, both are starting from the first index itself. Okay, after that we will write a stopping condition. So our I will stop at the m and our j will stop at the n. So if any of them reached at the m or at the n, our condition become false. If our condition become false, then this overall condition will become false, right? If it is a true, it is a false, then overall it is a false. If both of them are true, then it is a true. So in this case our j first becomes the false condition, so it become false, then the loop will stop. Now we have to write a condition to compare between the values. So we have nums of 1 I less than equals to nums up to of j. So we are saying we are comparing this value and this value. Okay, if this value is smaller and greater than this value, we will insert this value, okay, or we will insert this value. So for this we have to write also else condition. So else condition will handle the case where num values from nums2 is greater than the values from nums1. So also we have there answer vector. In this case, we will insert value from the nums1 and we will move our I. Similarly, we will insert values from the nums2, which is j, and we will move our j. Okay, so if we have smaller value from nums1, we will insert from the nums1 and move I. If we have smaller value from nums2, we will insert into the answer and move our j. Okay, I think here we made a mistake. When we had a same values, we will pick either one of the value. Okay, we will pick either one of the value and will move only one pointer. So in this case, we will be also taking 2 also, because we are merging sorted arrays, not we are removing duplicates. So the concept will remain same. So in that case, here we handle that case. If it is less than or equals to, means 2 less than equals to 2, the 2 will be inserted from this array and our I will move to the next value and j will still remain at this 2. Okay, and but still we need to handle this case, because in this case it might happens the both loops will end simultaneously, but in most of the cases it will not happen. So now we inserted the values. Now we have to handle 2 more cases where one of the loop already stopped. Means let's say our j loop finished, then we will pick all the values from the first loop and push it back into the answer and we will move. Similarly, in this we will push back nums of 2 of j. So both of the cases will handle our extra values which remains after stopping one of the loops. So this is our whole code. Now let's see what is the time complexity. Here you can see we are running our loop for the m and n simultaneously. So it will take m plus n, because in both the array we are visiting every value only one time. Similarly, this will be m and this will be n, but these are for the remaining values, so they might be in a very less number. So we can say our overall time complexity will be m plus n, and space complexity will be m plus n. It is for the answer. So this is our code. So now let's run it and see if it is working or not. So here all the details have been mentioned. You have given nums1, nums2, size of 3 and 3. Okay, here they have given you extra zeros, so we don't have to do with them because they already given a size of m equals to 3. That means we have to consider only these 3 values. Zeros are not included. Similarly, we have this example and here we have answer 1. Okay, so our final follow-up was we have to write a m plus n time complexity. So we have given m and n, so we don't have to take a size. Okay, there is one more thing they have mentioned here. They gave us a extra space. Okay, so we just have to make the changes in the nums1 and we don't have to return the nums1 itself, because it will automatically consider the nums1 and it will check for the answer itself. So in this case we don't have to declare new array or we don't have to return anything. We just have to update this nums1. Now we cannot directly update nums1, because if we try to directly update, we cannot directly update our nums1 because we are iterating over the nums1 itself. So we cannot do it because the values will got shuffled. So for this we have to declare a temporary array. So in that temporary array we can insert our answer, then after that we can assign that answer to the nums1. So first let's declare answer itself. Let's initialize our indexes, then our while loop I less than m and j less than n. If nums1 of I less than equals to nums2 of j, then we will push value from the nums1 because it is smaller than the nums2. After this we will move our I to the next index. Similarly, we will push here value from the nums2 and move our j to the next index. After that, we will also handle the cases where the values will remain. So let's first handle for the I less than m. Also, we don't need to check the condition, right? Because we know they are already sorted and we just have to pick the values and directly insert into the answer. Similarly, for the jth index, here we take nums2 and here we write j and here j plus plus. Now we will assign nums equals to answer. So the values from the answer will be assigned to the nums. Now let's run it. Okay, let's submit it. So here you can see it is working without any problem. So this is our whole code. Okay, here we are comparing values and picking up the smaller. Here we are handling where one of the array is still having some values. So that's it for today. Until then, thank you everyone, have a nice day.